Welcome. We're in lesson 59A. We're going to talk about advanced logarithm problems. Some of the logarithm problems that we've previously used can be reduced to one of the two forms shown here. So in A, the bases are the same. So we can cancel the bases out because they are the same. Because this is almost like a factor, this and this would allow us to divide both sides by that, which would then cancel both of them, which allows us to rewrite this logarithm as x plus 2 is equal to 5, which allows us to solve x is equal to 3 because we subtracted 2 from both sides. And B, we know we could rewrite using the base 4 with the exponent 2, just like this. We would say x plus 5 is equal to 4 with an exponent of 2, which would then be x plus 5 is equal to 16. Subtract 5 from both sides, x is equal to 11. And so then we must check to see that using 11 for x will result in a positive argument for that particular function. So we say x plus 5 is greater than 0, and then we would have 11 plus 5, which would be 16 is greater than 0, so that would work. So we always want to check to make sure that our solution in our logarithm is going to give us a positive number. That's one of the things that we have to check for because our problems are going to become slightly more involved, and that is going to require a positive outcome for our x value. So let's do a couple example problems to show you what I mean by that. So I'm going to pause and set the page up. So here is our problem, and it at first glance it looks complicated, but we're going to break it down into sides and remember our rules for logarithms. So on the left hand side we use the power rule, and so we would rewrite that power rule looking like this. The log of 10, we would have this as our exponent. Okay, remember whenever we have a coefficient we can rewrite it as an exponent here, and that's going to help us solve. And then on the right hand side we're going to use the quotient rule. Remember, whenever we're subtracting, it's division. So we would then rewrite that as the log of 10 is going to be 16 divided by 2. So this is how we would rewrite a problem like that using our rules. Then we would equate our arguments, which basically means we would cancel the parts that are alike, and we would write this as x cubed, just the way that is, and then we would go ahead and do the division problem here, which would give us 8. So then we know that we could solve this by transferring this to an index of 3 on this side. X would equal the cube root of 8, so x would equal 2. And that would be our solved problem. So you see how we can use our rules in these logarithm equations in order to solve for x. So let's try another one. So here we have the log of 7 in 59.2. We have the log of 7 with an x plus 1 answer plus the log of 7 with an x minus 5 answer is equal to 1, and 1 is going to be the exponent of the log of 7. So the first thing we're going to do is use the product rule, which means that when they are added, we are multiplying. So we're going to rewrite this first as the log of 7 is going to be x plus 1 times x minus 5, and that's equal to 1. Then we're going to use the exponential form and transfer this log of 7 over here. So it would look like x plus 1 times x minus 5 is equal to the base of 7 with the exponent of 1. So now we have it in a form where we can actually solve it. And the next step is to go ahead and do our distribution and then solve it to set everything equal to 0, which would then allow us to complete the square or use the quadratic equation, etc., 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 factor, whichever one works. So let's just go forth and do that next. So when we multiply these two together, what we end up with is x squared, and then that's going to be minus 4x because negative 5x, positive 1x gives us a negative 4x, and then that's going to be a negative 5, and 7 to the 1 is just 7, right? So then when we subtract 7 from both sides, we get x squared minus 4x minus 12 is equal to 0, because negative 5 and negative 7 becomes a negative 12. I'm going to roll this up just a little bit so I have some more room to write. Just makes it a little bit easier. So then, looking at this, we can factor this. So my factors of negative 12, that would turn into a negative 4, would be, I could say, negative 3, positive 4 would give me a positive 1. Nope. Negative 6, positive 2, that gives me a negative 4, so that's what I want to use. So we would factor that as x minus 6, x plus 2 is equal to 0, because it is factorable. That is the faster method. So it tells me that x is possibly, could have the possible roots of positive 6 and negative 2. Now we have to check and see that x plus 1 and x minus 5 are positive for both 6 and negative 2. And that's what I was talking about whenever we have to check our roots and make sure they work, or when we have to check our answers and make sure they work for the logarithm. And in order to work for the logarithm, they have to give us a positive number. It has to be greater than 0. So what we would do is we would check x plus 1 greater than 0, x plus 5, minus 5, greater than 0, and we're going to start with positive 6. 6 plus 1 gives us 7, which is greater than 0. So I'm just going to put that this is 6 right here. So that one works for that. And 6 minus 5 gives us a positive 1, which is greater than 0. So that works. So 6 works. Let's see if negative 2 works. So x plus 1, here's the negative 2. X plus 1, negative 2 plus 1 would be a negative 1. It is not greater than 0, so we can't even do it. It's not going to work at all. So negative 2 is not an acceptable solution for the original equation because it causes at least one argument to be negative. In fact, it would cause both of these arguments to be negative because it would make this a negative 7. So we can't use 2. So our only solution for x is going to be positive 6. So that is what we would write. We would write in our only solution, x is equal to 6 in our answer. So here's the next problem, 59.3. We're going to solve this equation with our log of 3. So the first thing we're going to do is we are going to use the quotient rule and rewrite this. So we would say, first of all, we would move this coefficient to here. So the first part is this. We do this. That's honestly supposed to be an x, and it is turned all kind of which way. Then we would use our quotient rule, which would put this into a division scenario. So we would say the log of 3 is x squared divided by x minus 2, which equals 2. So then we would look at this base as our base, and this is our exponent. So we would have x squared over x minus 2 is equal to 3 with an exponent of 2. So now we can solve from there. And so what we do to solve is we take this denominator and we multiply it by both sides after, of course, we do this. So we'll first simplify this and say x squared over x minus 2 is equal to 9. And then that becomes x minus 2 times x minus 2 on both sides, right? And that's in parentheses as well because we have to distribute to both of them. So the x minus 2 here cancels, and we end up with x squared on this side, and that's going to be equal to 9x minus 18. And then we're going to set this equal to 0, and we end up with x squared minus 9x plus 18 is equal to 0. So now we factor this, and when we factor this, we come up with the factors of -3 and -6 to get a positive 18. That would equal a -9. So x minus 3 times x minus 6 equals 0, which gives us two possible roots of x is equal to positive 3 or positive 6. So what we have to do is go back to our very beginning, and we have to check to see that x and x minus 2 would both give us a greater than 0 value. So x squared, all right, and our roots are 3 and 6. So x squared, is it greater than 0? And x minus 2, that has to be greater than 0. So when it's 3, we have 9 is greater than 0. So for 3, that works for that one. And 3 minus 2 is 1, so that's greater than 0. So our 3 checks. Our 6 squared is 36, and it is greater than 0. And then 6 minus 2 is a positive 4, and that's greater than 0. So the 6 checks also. So that means that both 3 and 6 are both solutions for x. And that checks out. And that's all I have for 59A. We've got a couple practice problems after this, and then we'll go into 59B. And the title of 59B is The Color of the White House. So I'll let you think about that until we get to that video.